Hi students, in this problem we're going to find the magnitude of a vertical electric field that will balance the weight of a plastic sphere of mass 2.1 grams that has been charged to -3 nanocoulombs. And we know that the Coulomb constant is 9 times 10 to the 9 newtons meter square over Coulomb square. So basically here we have, this electric field, right, that is pointing downward. And the letter we use to represent the electric field is the letter E. The electric field is a vector. And then we have this negative charge that is just in this electric field. So we know that the force acting on a charge that is in an electric field would be equal to the product of the intensity of the electric field times the magnitude of the charge. Force and electric field are both vectors. When the charge that is in the electric field is a positive charge, the direction of the force acting on the charge would be the same, the direction of the electric field. So if instead of this negative charge, we get here a positive charge, right? This force F acting on the charge due to the effect of the electric field will be pointing downwards exactly as the electric field is. But when you have a negative charge here, you know, uh, of course, then now the direction of the force acting on this negative charge will be opposite to the direction of the electric field. So basically what we have is that this sphere, this plastic sphere of 2.1 grams that have a charge of -3 nanocoulombs is under a force that points upward, and the force is due to the action of the electric field. Now, at the same time, in this plastic sphere, we have the weight acting on it, right? So remember that the weight is just pulling the force toward the center of the, it's pulling the sphere toward the center of the earth, right? It's just basically the force of gravity. So if we have, that the force F due to the electric field is going to balance the weight of the plastic sphere, we have to say that the force F should be equals to the weight, right, in magnitude. So we know that the weight is the product of the mass times the gravity, right? So we can say now here that then the force F, that is acting, and that must be acting on this plastic sphere to have it in balance, is going to be equal to uh, 2.1 gram. When you convert into kilograms, remember that 1 gram is 10 to a -3 kilograms. So it would be 2.1 times 10 to a -3 kilograms. Remember that when you convert from kilograms to grams, you say that 1 kilogram have 10 to the power of 3 or 1,000 grams, right? Times 9.81 meters per square second. That is going to give you a force of approximately, 0.021 newtons, approximately 0.021 newtons. So once you know this force, if you solve for electric field here using this equation, you can say that the electric field, magnitude of the electric field will be equal to the quotient of the force and the charge that is in that electric field. So you have that is 0.021 newtons divided by the charge, right? That in this case, this charge is -3 nanocoulombs. The prefix nano means 10 to a -9, so this would be 3 times 10 to a -9 coulombs, right? Okay, so now you will divide 0.021 newton divided by 3 times 10 to a -9 coulomb, and you will get that the electric field is equal to When you divide these numbers, you get 0.007 times 10 to the 9 newtons per coulomb. Rewriting this in scientific notation, of course, this would be 7.0 times 10 to the 6 newtons per coulomb. So this would be the intensity of the electric field that is gonna, you know, uh, mm, balance, right? The weight, or that is gonna be the cause of a force, that is going to balance the weight of the spheres, so that the sphere will be there in equilibrium, in that electric field. So it's also a very simple problem. It's only, to establish that there is an equality between the force due to the action of the electric field on the charge and uh, the force of gravity.